you can see right there, went ahead and got the aggressive angle on this awesome tip right here. Just ate it away real nice. Hit it with the file and then busted it up with the this little guy right here. It turned out pretty nice, pretty clean. So there you go. Gloves.
These are heavy-duty welding gloves. Now see, if you put the holy part on the part that you don't burn yourself with, it's new again. And this side over here, see, this side was good on both sides. So
There you go. Reversible.
you can see where the wire feed burns you though. Burns the gloves, burns Kevlar. Those are like brand new now. Shoot, they're just broken in. All right, this is not a TIG torch.
That is an air nozzle.
Is that what that was?
I think.
That's
the word on the streets.
I see that you have cleaned up my workbench nicely.
Mm-hmm.
Good. You're in my way. Get the hell out of my way. I can't weld if you're in my way.
So we're gonna hit that spot right there.
The oil leak, not the wiring hole.
Don't do the wiring hole.
And we're going to use the soft rod, which is 4043 if you read that. Here, you have to hold on to that.
Okay.
Let's see. Looks like I was doing some steel welding last time, so we're going to have to change out a tip. See, it has a sharp point, and it's small. Those are all sure signs that you've been welding steel. Of course, you do this after you put your gloves on, not before. See, with these fancy gloves here, I can actually work on stuff, see. Try that with your regular welding gloves.
No way.
Okay, so that's our setup for steel. See, it goes right next to the aluminum one that we're going to use now. That's aluminum.
What are the key aspects of an aluminum?
A hell of a lot bigger because it takes a lot more amperage. Like 3 times.
Okay.
Instead of welding at 50 amps, you weld at 250 amps.
There you go. Handles the business.
That's right. And you can tell I hardly get any heat in my torch at all.
Barely any.
This ain't one of those cheap Miller ones either. This is a good torch. Yeah, close enough. All right. Now we need to go to crater fill on, aluminum. Where's the other switch at? Aluminum. And we're not welding steel, so we go over here.
Go about what for the current control?
5 is a good number to go from.
225 for current
We
control?
went from like 70 up to 225. That's the difference between steel and aluminum. And you hit the on button.
Blah. And we'll get back to you when we're done. Alright.
Not really, but that works. Full of porosity, I'm sure. Die cast welds horrible. Do not grind that flush. Might uncover some unsuspected holes. Like those ones right there. See, the holes never end. Yep. Looks like crap. I think we gotta do some more welding.
Alright.
Alright. Looks Looks like the porosity ground through and it's got metal under it. Just to make sure we peen it a little bit. See how it goes down pretty easily? Smashing all the porosity. There's a hole right there, see it? Hopefully it doesn't go in anything important. Finally put oil to it.
Yep. Woo!
The joys of welding die cast. It sucks. See how the carbon?
Yeah.
It's all the crap that blew up out of the weld. We'll put the new weld, it's clean, but that's why I'm welding over the cover, and the cover keeps melting in front of you and turning to shit. It's a never-ending deal. Porosity on the outside edges, all the holes. That's the crap I'm trying to build. See, everything you weld, you keep more porosity. Wherever you weld, there's more porosity. The holes feel pretty good, but all around the hole's porosity.
Well, no one's gonna see it when it's on the bottom of the bike.
It just keeps bubbling up with big black turds. Look like eye holes sticking up at you. He just blows a big poof up in there like a balloon coming up.
Dang.
But it won't leak.
That's what we need.
Put a little Loctite on there, a little penetrating Loctite just to make sure, but I think it's a good weld where it matters, but all the external looks like crap. It can look like crap, it don't matter.